Here's how I solved the homework from Lesson 7, the motion problems. Question 1. Secret agent leaves Washington for Montreal, a distance of 950 kilometers, driving at 100 meters an hour. So, important information. From Washington to Montreal, we have a total distance. That's probably different. But from Washington to Montreal was driving at 100. Same time, another agent leaves Montreal for Washington at 90. How far from Montreal were they when they met to exchange information? So I'm going to do it like this. I'm going to have my Washington spy and my Montreal spy. We know that the total distance between these guys is going to be 950 kilometers. We know that the Washington spy is going faster, so he'll go farther. The Montreal spy is going a bit slower. I'm exaggerating here. So the Montreal spy is going 90. The Washington spy was going 100. And how far from Montreal? So that's going to be a distance question. So if I look at the distance, that'll be a total of x kilometers away. And then the Washington spy would have been 950 minus x kilometers away for the distance. For all these questions, we have to look at speed, distance, and time. So time, well, if they both leave at the same time, obviously when they meet each other, that's at the same time. So the time for both of these trips has to be equal. So I'm going to write that down. Time for both trips is going to be equal. And that's probably where we're going to get our equation from, but let's see. So I'm going to have speed times and distance, S, T, D. For my Washington spy, for my Montreal spy, and then probably have a total as well. And speed times time equals distance. Let's fill in what we know. Speed of the Washington spy was 100. Montreal spy was 90. The distance of the Washington spy, distance of the Montreal spy first, that was x. Distance of the Washington spy is going to be 950 minus x. Now time. Time's the last thing for us to fill in, and I'm going to write this over at this side. The equation for time, if speed times time equals distance, then time equals distance divided by speed. So distance divided by speed, that means that my time is going to be 950 minus x over 100. And the time for the Montreal spy is going to be x, it's his distance, over 90. Now we got to make our equation. And remember I said the time for both trips are equal, so that means our equation is going to be the time that the Washington spy travels, or 950 minus x over 100, has to equal the time the Montreal spy travels. And going back to grade 7, we solved this by cross multiplying. So I'm going to have 100x equals 90 times 950 minus x. So 100x equals 90 times 950, which is 85500. 85500 minus 90x. Bring that over, I get 190x equals 85500. Divide by 190. And I get that the distance from Montreal to the meeting place is 450 kilometers. If we go back and check how far were they from Montreal, that's what I needed to answer. I got the 450. I'd written down the answer. I'd written down the answer that Miss Fioroni had up here. That's the same as me. So it looks like I got that one right. Second question. Freight train left Thunder Bay for Vancouver. That's a long trip. Traveling at 90 kilometers an hour. 90 minutes later, a passenger train also left Thunder Bay for Vancouver, but it was traveling faster. How long after the passenger train left did it catch up to the freight train? Okay, so in this question, we've got Thunder Bay and we're heading towards Vancouver. So I've got the freight train and it is traveling at 90 kilometers an hour. 90 minutes later, the passenger train also left Thunder Bay but traveled at 100. So the passenger train is traveling, oh, let's do that green. Passenger train is traveling at 110 kilometers an hour. And then they catch up. So the distance is going to be the same because they catch up. They left the same place, they do catch up, so they hit the same place. We have two different speeds, but they're going to travel for different times. Okay, so I hadn't looked at this question before. I'm looking at it right now. I know it's going to be a speed times distance thing. I've got my freight train. I've got my passenger train. I know that the speed of my freight train is 90. The passenger train is 110. I know they go the same distance. So the distances are equal. Distances are equal. And I know that however long the freight train traveled, that the passenger train traveled that length of time, but then it says 90 minutes later. 90 minutes later, that's the same as 1.5 hours. So I'm going to, because my speed is in hours, I'm going to make sure that this is in hours. Time is in hours, so it's going to be x minus 1.5. The passenger train is going to travel 1.5 hours less than the freight train. Distances are equal, but if we do the multiplying, speed times time equals distance, I'm going to get 90x here, and I'm going to get 110 times x minus 1.15. And my equation comes from setting those two. Oh, I have more space here. So it's going to come from 90x equals 110 times x minus 1.5. Distribute 110 times 1.5 is going to be 165. So bring this over, it becomes positive, equals 110, so that's 20x. Divide by 20, and we get 8.25 hours. So let's check what they asked. This one asked, how long after the passenger train left did it take? So how long did the passenger train travel? So if we want to solve for how long the passenger time for the passenger train, that's going to be 8.25 minus that hour and a half that it went afterwards. So 8.25 minus 1.5 is going to give me 6.75 hours after the freight train, which happens to be the same answer Miss Fioroni got, so I think I got that one right too. Question 3. Two trains start at the same station at the same time but travel in opposite directions. One train traveled 11 kilometers an hour faster than the other one. So I'm going to have this guy's going at x. This guy's going faster, so his speed is going to be x plus 11. And this is for the speed. We know that the total distance is 635 kilometers. And we know that the total time is 5 hours. If one travel, determine the speed. So after 5 hours. So if I make my STD table, STD, and I've got the slow train, and I've got the fast train, and then total. So the slow train, the speed of the slow train is x, speed of the fast train is x plus 11. Time, well, they told us that one. They told us it was 5 hours. And it's going to be 5 hours for both of them, which is nice. Distance, Well, I'm going to do that multiplying thing. I know what my total distance is. I know my total distance is 635. But this one's going to be 5x. This one's going to be 5x plus 11. So my equation is going to come from here. That plus that equals 635. So 5x plus 5x plus 11 equals 635. 5x plus 5x plus 55 equals 635. 10x equals 635 minus 55, which is 580. So 10x equals 580. So x equals 58. Hey, I got that one right. So the first speed was 58 kilometers an hour. The other speed going the other direction is 58 plus 11. So 58 plus 11 equals 69 kilometers an hour. So I'm going to have my two things, 58 kilometers an hour and 69 kilometers an hour. So there's that one. Number 4, a jet flew from Toronto to Paris at 80 kilometers an hour, returned going slower. Okay, so we're going to have Toronto, we're going to have Paris. On the way here, my speed was 800 kilometers per hour, and on the way back, 700 kilometers per hour. And I know the distances are going to be equal. Distances equal. Okay. Because it doesn't matter there or back, we're going to assume it's the same distance. If the total trip, not including stopover, took 15 hours, so there and back, my time is 15 hours, determine how far it is from Toronto to Paris. Okay. Speed times distance. Speed times time equals distance. So from Toronto to Paris, the speed was 800. From Paris to Toronto, the speed is 700. Total time, 15 hours. Distance, well, we're going to have to figure that out. But we know that the distances are going to be equal, so we'll do that. I'm going to let x be the distance, the time it took to go from Paris to Toronto, from Toronto to Paris. If we were going faster, that one's going to be less time. That means that Paris to Toronto, because we were going slower, that's going to be 15 minus x. And speed times time equals distance. So I'm going to have 800x here and 700 times 15 minus x for my two distances. Now the question, because we're going there and back, the distances are going to be equal, so I'm going to use that to get my equation. So I'm going to have the distance from Toronto to Paris has to equal the distance from Paris to Toronto. And if I distribute 700 times 15 equals 10, 500 minus 700x. Bring it to the other side, I get 1500x equals 10. 500 divided by 1500. So 10, 500 divided by 1500, and I get 7. So I get my my time from Toronto to Paris. I just solved that. My time for Toronto to Paris is 7 hours. So that means that the distance is going to be 7 times my 800 kilometers per hour. So I'm going to get 5600 kilometers, and that's right. So there we have the solutions to the lesson 7 homework.